Now move to the next problem. Okay, see, read out your problem. Find the Fourier series of the periodic function which was defined as f of x equals to minus pi from minus pi, where x lies between minus pi to 0, and equals to x if x lies between 0 to pi. That means in your graph, your function f of x equals to minus pi from, this is your value, minus pi from minus pi to 0, and x from 0 to pi. Okay, this is your graph. Since it is a periodic function, we can represent it like this. Now, see the solution. What is your function f of x? F of x equals to minus pi from minus pi to 0, and this value will be equals to x from 0 to pi. Now, what will be your expansion? Your expansion formula will be f of x equals to a naught by 2 plus sigma n equals to 1 to infinity a n cos n x plus b n sin n x. Let it will be equation 1. Okay, now write down the formula for a naught. What is the formula for a naught? Your interval is minus pi comma plus pi. So your formula will be 1 by pi integral minus pi to plus pi f of x dx. Okay, now it can be splitted into 1 by pi integral minus pi to 0 f of x dx plus integral 0 to pi f of x dx. Write down or substitute the values of f of x in the corresponding intervals. That is, from minus pi to 0, what is your f of x value? See your function. From minus pi to 0, your function value is minus pi. So, substitute it here. Okay, similarly, from 0 to pi, what is your function value? X. F of x equals to x. Substitute it here. Now, integrate it. After integration and evaluating the integration values, you got minus pi by 2. So, you got a naught value is minus pi by 2. Keep it aside. Now, calculate a n. Write down the formula for a n. What is the formula for a n? A n equals to 1 by pi integral minus pi to plus pi f of x cos nx dx, isn't it? Now, substitute the values of f of x in the intervals minus pi to 0 and 0 to pi. Okay, now substitute those values. Here, I substituted here. Observe this one. 1 by pi integral minus pi to 0 minus pi cos nx dx plus integral 0 to pi x cos nx dx. Now, after integration, take the constant out, minus pi, and for integral cos nx, what is integral cos nx? Nothing but sin nx by n. Apply the limits 0 and minus pi. This will be equals to sin 0 minus sin minus n pi. Sin minus n pi, nothing but sin minus of sin n pi. So, and after substituting these values with the support of this formula sin n pi equals to 0 for every n belongs to z. So, the first part is equals to 0. Now, see the second part. X cos nx integral 0 to pi x cos nx dx. One is u and another one is v. Now, integration. After integration, you get x sin nx by n minus 1 into minus cos nx by n square. Leibniz rule. You are following Leibniz rule. This equals to, and substituting this equals to pi sin n pi by n plus cos n pi by n square minus. Now substitute the lower limit. 0 minus into minus cos 0 by n square. Finally, you got minus cos 0 by n square. This will be equals to an equals to, substituting the formulas, you got an values here. Clearly, n not equals to 0. Okay, now you have to calculate bn value. Write down the formula for bn and substitute the function values in the corresponding intervals. That is, in from minus pi to 0, what will be your f of x? That is minus pi. I wrote it here. And from 0 to pi, your function value is x. We write like this. Now, after integration and evaluation, simplifying the value, you got bn is equals to this one. Now, bn value equals to 1 minus 2 into minus 1 power n by n. Clearly, n not equals to 0. Now, substituting the a0, an and bn values in equation 1, you got f of x equals to minus pi by 2 by 2 plus sigma n equals to 1 to infinity minus 1 power n minus 1 by n square pi cos nx plus 1 minus 2 minus 1 power n by n sin nx. Now, expanding the summation as minus pi by 4 plus, write down the cos terms here and sin terms here, we get minus pi by 4 plus minus 2 by 1 square pi cos x plus 0 minus 2 cos 3x by 3 square pi plus 0 and so on. Similarly, observe the second term, put n equals to 1, 1 minus 2 into minus 1 by 1 sin x, that is 3 sin x by 1 minus sin 2x by 2 plus so on. This is a required Fourier series expansion. So, we calculated the Fourier series expansion for the given discontinuous function. Now, we have to deduce the relation. Observe your relation and find out the suitable value of x. Here, this is your relation 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. Then, observe your expansion. This is your expansion. See, for what value of x you will get 1 by 1 square and so on format. So, by choosing x equal to 0, we get f of 0 equals to minus pi by 4 minus 2 by pi cos 0 by 1 square plus 2 by pi cos 0 by 3 square and so on. Sin 0 is 0. So, the second term is totally equals to 0. Now, finally you got this value and you observe that at x equal to 0, 0 is the point of discontinuity. At x equal to 0, the function is discontinuous. So, now since the function is discontinuous at x equal to 0, by using this point, if x is the point of discontinuity, your Fourier series expansion will be like this. So, you have to write the left and right hand side limits for f of x and take the average of that. By using this point, we have to calculate the left and right hand side limits for their function. See your function. This is your function. So, your at x equal to 0 is the point of discontinuity. Then, calculate the right hand side limit and also the left hand side limit. What will be your right hand side limit and left hand side limit? It will be f of x minus 0. Here x equal to 0. Okay, x nothing but x is 0. So, f of 0 minus 0 nothing but minus pi. 0 minus 0 nothing but minus pi. Similarly, f of 0 plus 0 is nothing but 0. This will be observed from your function. X less than 0. Your function value is minus pi. So, the value of f of 0 minus 0 nothing but minus pi. And here the right hand limit at x greater than 0, your function value is 0 and the right hand limit will be 0. So, f of 0 will be equal to the average of right hand left hand side limits, nothing but minus pi by 2. So, this will be equals to minus pi by 2 equal to, after substituting, this will be equals to minus pi by 2 equals to minus pi by 4 minus 2 by pi into this one. So, after simplification, you got the value. That is, you got the series 1 by 1 square plus 1 by 3 square plus so on, nothing but pi square by 8. Is it clear? So, we discussed the Fourier series expansion for discontinuous functions in the limits 0, 2 pi and at minus pi, plus pi. Not only that, we also discussed problems at a point of discontinuity and at point of continuity. Is it clear? Now we will discuss the same concept, that is Fourier series expansion for discontinuous functions, for even functions and for odd functions. Now let us see a problem. Read out the problem. Obtain Fourier series for the function f of x which was given by f of x equals to minus half pi plus x for minus pi to 0 and half into pi minus x for 0 less than or equal to x less than pi. That means your function is a discontinuous one, and what will be your interval? Here your interval is minus pi plus pi. So, if it is minus pi plus pi, if the interval is minus pi plus pi, you can check whether the given function is even or odd in order to calculate the Fourier series expansion. Now, how to check even or odd? Let us substitute. See the definition of even and odd functions. Let us see. Substitute f of minus x. That means replace x with minus x in your given function f of x. If you got the same value, you can conclude it is an even function. If you got the negative of your function, you got it is an odd function. And also we can conclude the given function is odd if it is symmetrical about origin. Then also we can confirm your function is an odd function. Let us see that one. First, write down your function f of x. Replace x with minus x. What it will be? Minus half into pi x. In place of x, we have minus x. So, it is minus x. In the interval minus pi less than minus x less than or equal to 0. Similarly, here also 1 by 2 pi minus of minus x, nothing but plus x. So, we got it here. Now, after simplification, you got this value is equal to minus of your function f of x. Minus f of x. So, you got f of minus x equals to minus of f of x. Then, what type of function is it? It is an odd function. If the function is odd in an interval minus pi plus pi, which values will be equal to 0? A0 and an. So, it remains to calculate only bn. What will be your formula for bn and what will be your f of x? First, write down that one. Your Fourier series expansion of f of x will be given as f of x equal to sigma n equal to 1 to infinity bn sin nx. That it will be equation 1. So, you have to calculate only bn value. Write down the formula for bn. What will be the formula for bn? Your bn equal to 2 by pi integral 0 to pi f of x sin nx dx. Okay, now 2 by pi integral 0 to pi f of x. What is the value of f of x in the interval 0, pi? See the function. In the interval 0, pi, your f of x equals to 1 by 2 pi minus x. So, substitute this value in your formula bn. This equals to 2 by pi integral 0 to pi. Your f of x is 1 by 2 pi minus x sine nx dx. Now, by using Leibniz rule, we have to find out the integration. That value will be equals to minus 1 by pi. After simplification, minus 1 by pi minus x cos nx by n plus sin nx by n square. Now, apply the upper limit and lower limit. What is your upper limit? Plus pi. And lower limit? 0. Substitute the upper limit first. That is pi. Pi minus pi cos n pi. Pi minus pi means the first part is 0. Sin n pi. Using this formula, this is 0. So, the first value is 0. Now, substitute the lower limit. Pi minus 0, nothing but pi. Cos 0 is 1. So, pi cos 0 by n, nothing but pi by n. Plus sin 0. Sin 0 is 0. So, you got minus 1 by pi into minus pi by n, nothing but 1 by n. Your Bn value is 1 by n. Now, substitute this Bn value in equation 1. You got f of x equals to sigma n equals to 1 to infinity 1 by n sin nx. Now, expand this summation, you get the required Fourier series expansion for f of x. Is it clear? Now, please go through these practice problems. See the first problem. Find the Fourier series for the following function. This is your discontinuous function. What is your interval? Your function is f of x equal to 0 from minus pi to 0 and pi x by 4 from 0 to pi. So, totally your interval is from minus pi to plus pi. What is the point of discontinuity? 0. This is the point of discontinuity. From minus pi to 0, your function f of x equals to 0. And from 0 to pi, your function value equals to pi x by 4. Now, evaluate the Fourier series expansion in the interval minus pi comma plus pi. First, write down the formula f of x equal to a naught by 2 plus sigma n equals to 1 to infinity a n cos nx plus b n sin nx. First, calculate a naught value and then a n value and b n value by using the formulas. Okay, now see, calculate the values. Here you got these answers. Check it out with your answers. And to deduce this relation, I want to give you a hint. Put x equal to 0 in your final expansion. Then you get this result very easily. Just see the function, find out the interval, substitute the formula. You get the result. Now see the second problem. In this, what I asked is, first I gave you a function f of x. Is f of x even or not? You have to check whether the function is even or not. What we have to do? You have to replace x with minus x in your function f of x. This equals to f of x. Then we can conclude f of x is an even function. Okay? If not, we said that if we got minus f of x, you get odd function. First, check the condition. And then obtain the Fourier series. If it is odd, you already solved one problem. You can follow the previous problem. If it is even, what will be the formula? If it is even, your formula will be f of x equals to a naught by 2 plus sigma n equals to 1 to infinity a n cos nx. Here, bn will be equals to 0. Now, calculate a naught and a n values. What will be the formula of a naught? 2 by pi integral 0 to pi f of x dx. Similarly, you can write the formula an. What is the formula for an? 2 by pi integral 0 to pi f of x cos nx dx. Now substitute the value of f of x in the interval 0, pi. What is the value of f of x? If the function is even, you have to take this one. That is 1 minus 2x by pi. Okay, substitute those two values and calculate a0 and an values. Substitute those two in your equation. Let it will be equation 1. In your equation 1, you get the Fourier series expansion. Is it clear?